This genuine Unreal Engine 5.5 run starts with 48 agents on a regular grid, each carrying a different velocity. Separation opens space between close neighbors. Alignment rotates local groups toward shared headings. Cohesion pulls those groups back toward nearby centers, while edge steering keeps the simulation inside its test area. In this lesson, we will search a local neighborhood, calculate 3 independent steering vectors, weight and clamp their sum, limit speed, update all agents from the same state snapshot, render positions and headings with instanced meshes, and verify the result with automation plus 4 native Unreal captures. For one Boid, loop over every other position and skip itself. If distance is above the 250-unit neighbor radius, ignore that agent. Otherwise, accumulate its velocity and position. If it is also inside the 92-unit separation radius, accumulate an inverse distance repulsion vector. This demonstration uses a direct and squared search because 48 agents keep the code easy to inspect and test. For large crowds, replace only the neighbor lookup with a spatial hash, uniform grid, or Unreal mass query while preserving the steering rules. Separation starts with this Boid position minus its neighbor position. Dividing by distance squared makes nearby agents contribute much more strongly than agents near the edge of the separation radius. Sum those offsets, normalize the result, multiply by maximum speed, then subtract current velocity to obtain steering. The final force is clamped to 360 units per second squared. The red separation phase gives this rule the largest weight, and the minimum distance metric proves that the flock is not merely drawing overlapping points. Alignment averages the velocities of all neighbors inside the larger radius. Normalize that average and multiply by maximum speed to create a desired velocity. Desired minus current velocity is the alignment steering vector, again clamped by maximum force. The yellow phase raises alignment weight and reduces separation weight, so the small heading markers begin pointing in similar directions. The measured average dot product rises further during the final phase and reaches about 0.97, where 1 means parallel headings. Cohesion averages neighbor positions to find a local center. Subtract the Boid position, normalize, multiply by maximum speed, and subtract current velocity. This uses the same desired velocity pattern as alignment, but the input is location instead of heading. If cohesion is too strong, the flock collapses and separation fights it every frame. If it is too weak, aligned groups drift apart. The final green phase balances all 3 rules and reports a flock radius near 430 Unreal units. The phase selects weights for separation, alignment, and cohesion. Add the weighted vectors, add edge steering near the test limits, clamp the total acceleration, and integrate velocity with delta seconds. Speed stays between 145 and 330 units per second. Write every result into a next velocities array first. Only after all 48 agents have read the same old state do we replace the velocity array and advance positions. Updating one agent in place while later agents read its new value would make results depend on loop order. These are 4 genuine game mode frames from one compiled Unreal execution. Ready shows the regular grid and randomized headings. Separating opens gaps while the red state is active. Aligning shows local groups turning in common directions. Cohesive shows strong heading agreement, a compact moving formation, and the purple history of one tracked agent. Every cyan body, velocity marker, green center marker, trail point, state label, minimum distance, alignment score, edge steering count, and instance transform comes from the included C++ project, not generated substitutes. The Unreal automation test passed with 1 success and 0 warnings or failures. It verifies 2 detected neighbors, 2 separation contributors, repulsion away from positive X and Z, alignment toward neighbor velocity, cohesion toward the local center, force clamping, zero output with no neighbors, and the configured radii. Speed and force limits. The real runtime recorded more than 920,000 neighbor interactions, more than 345,000 close separation events, over 13,000 edge steering applications, 60 trail points, 1,200 steps, all 4 captures and valid true. The reusable pattern has 4 parts. Query a local neighborhood from a stable state snapshot. Calculate independent steering intentions. Combine and clamp them with explicit weights. Integrate every agent into a new state, then render the result. This demonstration intentionally omits collision avoidance, goals, predators, 3-dimensional banking, networking, and a faster spatial index. Add those as separate tested rules instead of hiding them inside one giant tick function. For AI-assisted Unreal development, Boids are friendly because vector directions, numeric limits, visual states, and regression gates all make incorrect code observable.